We're going to continue in this session the lamp problem that we were on previously. I hope you've still got that one with you. If not, remember we had them in parallel, and a lamp blew. And what did we do? We said, righty-ho, it's going to change, and it's essentially taking a bulb out or flicking the switch so that no current flows, and the bulbs glow equally bright as they used to. Because why? The current has adjusted to the new resistance. Now in the next one, we're going to do this. We're going to have our bulbs. We're going to call it the same bulbs. Okay? And they will say to you, without doing any calculations, etc., what happens here? You know what? On your paper, you can just assign 2 volts or resistance, just assign R, 2 ohms to each one, and then add it up. And just give your battery a voltage, okay? Do it on your thingy, and then you can explain it in words. Let's have a look here. So this is V across here still, isn't it? Okay? That V is the same. It's not changed. It's the voltage on the battery itself. R is R is R is R. Are we given? Yes. Total circuit resistance is equal to R plus R plus R, which is equal to 3R. Okay, well, that's very straightforward. Therefore, can I work out on the circuit? Let's have a look. I know my spelling. Not my spelling, my writing's not great. I do apologize. But what have we got here? We say on the circuit, V equals IR. Hang on, I know total there, and I know V is the voltage. I is equal to V over 3R, isn't it? Because that's R total over there. So I is equal to V over 3R. So now I can go back. Let's go and put in our current. Remember here, this is a voltage splitter, isn't it? So I'm going to put my voltage in green. V. This is V1, V2, V3. Okay. Now, what can we say about V1, V2, V3? We can say V total there is equal to V1 plus V2 plus V3, can't we? We know that because the sum of the voltages in the circuit must be equal to the battery, because it's the only thing that we've got that's supplying a voltage or an EMF. Let's look, what do we do now? Well, let's go and solve the circuit, shall we? Because they're asking about the brightness of the bulbs. Maybe they're asking to each other or relative to the circuit that's parallel. We'll look at it both ways. Let's see. Okay, let me just bring this down a wee bit here to keep it. And then if you don't mind with your indulgence, I'm just going to write on the side so that we can refer back. So let's have a look. I is going to be V over 3R. So let's put it in. Is going to be equal to V over 3R is equal to V over 3R is equal to V over 3R. Therefore, power is equal to I squared R, right? I squared is V over 3R, all squared times R, which is V squared over 9R squared times R, which is equal to V squared over 9R. So the power of each bulb is V squared over 9R. Okay. What does that actually mean then? It means that the power is there. What was the power on the previous one? Well, the power on the previous one, I've got it here. Oh, I'll do it later. There's a whole scenario where I've done it. So what do I do now? Now what I do is I say, okay, the power of each one is V squared over 9R. So no, they're not as bright as the previous, but we'll look at that just now. But what happens now if bulb number 2 blows? Okay, all right. Bulb lamp 2 blows. Okay, what happens to the brightness? Can a current flow when the bulb is blown? No current. Why not? Because, guys, a bulb looks like this, okay? I'm not an artist. I've said that before, right? Let's say it's the screw-in type. goes up there, and you've got your little filament across there. That was not bad. Okay. When it blows, that wire breaks, which means the electrons can't flow. If the electrons can't flow through lamp 2, they can't flow through 1 or 3. There's no circuit. Okay, therefore, no light. Okay, it's extinguished. This is why you find, I don't know if you've ever had that mishap where you unpack lights for a tree once a year, whether it be whatever the festivity is that you're doing, and all of a sudden it's dead. You have to go and check each bulb one at a time, don't you? Because they're all in series. And that is such a pain, is it not? Some of them, however, are linked into parallel, which is quite cool, because what it means is each bulb goes out. If it pops, it doesn't really make a big deal to you. Now, then let's have a look. Compare the circuit 1 and 2, they say to us, right? Compare the circuit 1 and 2. Now, if you remember, circuit 1 and circuit 2. Circuit 1 was this one, correct? Like so. I know that's not really neat. And circuit 2 was like this. Okay. Circuit 1, I'm just going to do it for bulb 1 in each case. It doesn't matter, bulb 1, 2, or 3. So let's have a look. Power was equal to V squared over R. In this case, power was equal to V squared over 9R, right? So say V is equal to 12 and R was equal to 4 ohms. So the power here is going to be 144 over 4, which is equal to 36 watts. Over here, it's going to be 144 over 9 times 4, which is going to be 4 watts. This is the parallel circuit. This is the series. So your bulbs in your series glow less brightly than in the parallel section. Okay. Remember, if you get one of these in a test or just assign a 2 voltage to each resistor and a 4 volt or 12 volt to a battery, or 24, just a nice even number. And you can very quickly work it out. It takes a few seconds. Okay. Right. So we've looked at that now. Now let's have a look at circuit number 3. Circuit number 3, my apologies. I'm just going to go onto a new piece of, do I call this paper? I guess, electronic paper. So we're going to a new one. Now the circuit that is very sort of liked, okay, is this one. And now they put a bulb down over here and call it lamp 1. Okay, then we go up to a bulb over there and we go to another one down here. All right, and now we're going to have a look at this. And I'm going to put a switch over here, call it S1. I'm going to call this lamp 1, lamp 2, and lamp 3. Okay, now they say, now what? Okay. Well, hang on, we've got to work it out. Well, what do? Step 1, we call each, put the current in, right? This is I, this is I1, this is I2. So step 1, I put my current in. Then I see, am I given all the resistors? Well, yes, because they tell you that each one is the same. If they perhaps tell you that lamp 3 is twice the resistance of lamp number 2, you would just basically, in your equation, you would have it as 1 over R parallel is equal to 1 over R1 plus 1 over R2. Now, in my case over here, the one I've got, they are all the same. So therefore, 1 over R parallel, you'd label it obviously parallel pair here. 1 over R parallel is equal to 1 over R plus 1 over R, which is equal to 2 over R. Therefore, R parallel or R effective is R over 2. And we can go and we can put in our, I've just called it a ghost resistor or ghost bulb, R over 2, because a bulb is a resistor, isn't it? Okay. What if they told us, they said lamp 2, let me just erase that, sorry. Lamp 2 is twice R1. You'd say then that's going to be like so. Plus 1 over 2R1. And then your base would be 2R1. And you'd have that goes in 2 plus 1, which is going to be 3 over 2R1. Therefore, R parallel is 2R over 3. Okay. Can you see? You just put in, substitute, so that you bring them all to R. Okay. Now, therefore, I know R. I've broken it, but hang on, I've got another resistor. So R total is going to be equal to R plus R over 2, which is going to be 3 over 2R. And you can see here, R total would be R plus 2/3 R. Right? And you just carry, and you do the same recipe. Okay, I think I have done one of these in the exam or test prep side, but just follow the same recipe. It's just straightforward, which is going to be that. Therefore, and remember the voltage of the battery is constant. So therefore, V equals I. V equals I. Hate it when it does. Oh, come on. That. Okay, so I say V is equal to IR. I'm now talking for the circuit, the whole circuit, right? So therefore I for the circuit is V over total resistance, which is V over 3 over 2R, which is equal to, what do I do here? I tip and times it, don't I? All right, and I end up with it being equal to 2V over 3R. That's I. Now let's go back to the circuit, shall we? Change to a red pen. All right. Let's go back to the circuit and put it in. Okay. And we put it in. We say, okay, I over here is equal to 2V over 3R. It splits into 2 here. So I1 must be a half of 2V over 3R. Which is going to be equal to V over 3R. So I here is V over 3R, and I2 is equal to V over 3R. Now let's go to the bulbs and see what happens, because we know the current and we know the resistance. So let's say lamp 1. Okay, that's the first one in that the current gets to. We say power is equal to I squared R. I squared is going to be 2V over 3R all squared multiplied by R, which is going to be 4V squared over 9R squared times R, which is 4V squared over 9R. Correct? There we go. 4V squared over 9R. Okay. Then we can say, right, this is going to be, let me just take that out the bracket, V squared over 9R. Okay, like so. Now let's go to lamp 2. Okay. Lamp 2. What happens at lamp 2? What is the power? Power is I squared R. What is the current going through there? V over 3R squared times R. That is going to be V squared over 9R at the end of the day. Can you see there? So hang on, lamp 1 is getting 4 times the power. So lamp 1 is 4 times as bright as lamp 2. It's 4 times as bright as lamp 2. All right? But it's not as bright as bulb 1 in the previous. Okay? Let's just have a look. We say, all right. Now, what happens? Let's just say, what if they say we open the switch? Whoops. Now, okay, let's just put in some numbers. Once again, say V is equal to 12 and R, 12 volts. R is equal to 4 ohms. Let's calculate this just so that you can see. The power here is V squared over 9R. which is going to be 144, 12 squared, over 9 times 4, which is going to be 4 watts. The power at the top here is going to be 4 times 4, which is equal to 16 watts. Okay? Can you see 16 watts, 4 watts? Okay. Now, open switch S1. Let's open switch S1, shall we? What happens now? Well, if I open switch 1, what happens? Let's go back. Switch 1 is open. Therefore, I've now got R total is equal to R plus R, isn't it? Why? Because it's R, my circuit looks like this, hey guys? Like that, with an R and an R. The other one that was over here is now gone. It's blown, or whatever, is equal to 2R. Once again, you go back and you say I is therefore V over 2R. Therefore, okay, the current is now going through each one. I is equal to V over 2R. I equals V over 2R, correct? So I can now say, therefore, power is going to be I squared R. I squared is V squared over 4R squared times R, which is V squared over 4R, which is going to be equal to 12 squared, using the 12 volts again, over 4 times 4, which is 144 over 16, which is going to be equal to 9 watts, okay? So what happens in this situation? It glows brighter. Remember, what did we have first? Let's just go back to our circuit, okay? Let's just use this opportunity and go right back to the circuit over here, all right? We had, I'm going to put it in blue, all right? Blue, we had over here, that one was glowing at, lamp 1 was glowing at 16 watts. And these were glowing at 4 watts. Right? That was open like that. Then along I come and I say, right, I now change it. Okay, I'm going to have to change it to green. And I say, this one is blown. This was my last one. And now they both go to 9 watts. Okay, so that's what's happened. Originally, lamp 1 was 16, the others were 4. So then one blew, and what happened next is they went into series, and therefore they each glow with 9 watts. Not as bright as the first case, and the second lamp was not as dim. Okay, as I say, if you get stuck, please just assign a voltage and a 2 ohms to each one. Now I'm going to do another problem. Okay, not this lamp problem, this one that I called the quintessential problem. I'm going to do another circuit where we've got a few bits and pieces. Okay, they say here each lamp is identical, and they're going to give us a circuit with some voltages and some reading. There's some readings. This one does have an internal resistor of the battery. I know that's in the next section, but let's just have a look at it. Pretend it's a resistor on its own. So this example looks like this. Okay, I've got a circuit, right, and they do this. And they put a thing there and they say that this is 1 ohm, and they put it into a little box like that. That essentially is R, is the little internal resistance, okay? Just if you go through this one with me, you'll see how it comes into the next section. We don't really need to do the whole internal resistance. You can solve this one without it because I set it so. Okay, so we go down here and then they tell me that, let's say I have a, I'm going to come across a bulb over here and I'm going to put an ammeter, call it a 1 over there, and we're going to go across. Up over here, I've got a 2 and another bulb, like that. Down here, I've got 2 bulbs. And an ammeter is a 3, okay, like so. And let's have a look. Each lamp is identical and the reading on V2 is 6 volts. Let me find where I put V2. I said V2 was here. And they say that that is 6 volts across there. All right. And the reading on A3 is 1.5 amps. This is A3 here, 1.5 amps. Right. Therefore, now they say, find the readings on everything else and find the EMF of the battery. In other words, solve the circuit. Okay, step 1. First is, number 1, put in the current. Positive to negative at every single place where there's a component. It splits here to I1, I2, right? Then I say, okie dokie, right? I'm going to put a voltmeter over here and a voltmeter over there, okay? And let's call them V3 and V4, all right? Voltmeter was V2 is there, and V1 was over here. Now remember, if they don't put voltmeters there, you can just put it yourself, and because it's going to help you to solve it. You just stick a voltmeter in there and work out the voltage. Now, what is the next step? Okay, the next step is they tell me, okay, and they say that each lamp is identical, blah, 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 blah. All right, let's have a look. They've told us that's 1 ohm. Let us find where have we got information. Well, let's look. At this lamp here, I've got nothing. All right, I don't know anything at that point. Let me have a look. Over here, I know voltage, but I don't know current or resistance. But, hold on a seckie. Over here, I've got a current. What do I know? I know that the voltage over here is equal to 6 volts. Why? Because it's a parallel. The voltage over parallel is the same. Because over here we've got a what? We've got a current splitter. Therefore, the voltage must be 6 volts across there, which is correct. Therefore, if it is 6 volts across there, okay, we look at that, the voltage across the branch is that, and I can say that therefore V3 plus V4 must be equal to 6 volts. But now here, remember, they told us that the resistance is R, 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 and R. They are all the same. Hold on. That means that V3 and V4 must be the same. Correct? Because you've got the V there and the V there must be equal. It's split equally because that section is a voltage splitter. The current is the same. Let's look at it. Okay, just go through it with me here. The I is the same, right? Now let's just do a quick calculation on this, shall we? Let me move it up a bit. A quick calculation. Let's look. V1, and let's call that V2. V1 is equal to R, and R is the same. V1 is equal to I times R. Okay? And V2 is also equal to I times R. Isn't it? Okay. So therefore, the voltages are split evenly. Therefore, it's going to be equal to 3 volts. All right? But you've also got 1.5 amps that you know are going through there. Right? So you could say it like this. R total, just for this branch here, right? Just for these two, is equal to R plus R. I'm just looking now from, let's call this A to B. Okay? From A to B. Okay? R total is R plus R is 2R, isn't it? Okay, R total is 2R. There they are. R and R, so it's 2R, right? And therefore, the V is equal to I times R. So therefore, V across we know is 6 volts is equal to I is 1.5 times 2R. Okay, therefore R is going to be equal to 2 ohms. Can you see? I've solved for R, it's 2 ohms. What do I do now? Now I go back and I put it in onto my thingy. I'm going to actually put it in red. So this is going to be equal to 2 ohms. This is going to be equal to 2 ohms. This is 2 ohms. This is 2 ohms over there, isn't it? Can you see what I did? I just said V 6 volts across there, and the current is 1.5, and the total resistance is that. Straightforward, is 2. Now we're in a pound seats, aren't we? Because I've got I there is going to be 1.5. So hang on, we now know across this resistor here, okay, we know there, we can say the following, can't we? We can say that, let's say across, lamp 2, right? Let me just check that I called that lamp 2. I didn't. Let's call this lamp 1, lamp 2, lamp 3 and lamp 4. All right. Okay, lamp 2, across lamp 2, which is the one on its own up here. All right, there we go. Across lamp 2, what have we got now? Well, lamp 2, V equals IR. We're going to that component. V, they've told us, is 6. I, we don't know. R is 2. Therefore, I is going to be 3 ohms. Now I go back. Let's go and put it in. Okay, red. Let's go up. Now I can put in that this is equal to 3 amps. Hang on, this was 1.5. So this must be equal to 3 plus 1.5 is 4.5 amps. This is equal to 4.5 amps. So now we can work out the voltage across V1 over here, can't we? Okay. What do I say? I say, start a new page. I say that V1 is equal to IR. So V1 must be equal to 4.5 amps multiplied by 2, which is equal to 9 volts. Therefore, V of the circuit, okay, is equal to 9 plus 6, which is equal to 15 volts is the circuit, right? So the reading on a voltmeter across the battery would be 15 volts. The last thing I have to do, because they've asked us calculate the EMF of this circuit, is I say, right, I've got everything else. All I now need to do is go back, and here's where I say it's treated exactly the same. We're now going to look over here, right? Now remember, what happens is the current is coming through here. I here is equal to 4.5 amps. R, the internal resistance of the battery, which is what causes it to get hot, is 1. So therefore, what is the voltage across here? The voltage across there is going to be equal to, okay, the voltage across that one over there, voltage, this is across the 1 ohm, or what is called the internal resistance. Okay, voltage is equal to IR, which is 4.5 times 1, which is 4.5 volts. Therefore, the EMF of the battery is V circuit plus V, I'm going a bit too quickly, plus V, it's called lost volts, but V across the internal resistance, I like to call it V drop. The voltage in the circuit we said was 15, okay, and the other one, I think it was 15 volts, I must just check myself. No, 14 volt, let me just check, 14, 9, 10, 15 volts, 9 volts and 6 volts. 10 is 15 volts plus 4.5 volts is equal to 19.5 volts. All right. You can check my pushing time here, but we've got 15 volts was the circuit because we said 9 volts and 6 volts, 10 is 15. Look at the internal resistance 4.5. So we basically got 15 plus 4, 19.5 volts. That's the EMF on the battery. That we deal with in the next section. Okay. We've just made it through. Please go through these. And you know what? As you do one or two, you start seeing the little tricks. You look for if you've got total resistance. If not, find 2 pieces of information and work out from there. There are plenty more still to come. And as I say in the test section, there's more. And I know I keep saying in many videos, we're going to load more and more and more onto the system as we sort of develop it over the next couple of years. Cheers, have a great time. And I hope that the circuits, which for some reason to many people seem to be a problem, I hope it's not. I hope it's enjoyable and you can see what's going on. Cheers. Bye.